Hey there, future engineers, let's talk blueprints. You know those drawings that tell you exactly how to build something? They're like a secret language, and today, we're cracking the code on one of the most important parts: orthographic projections. Now you might be thinking, projections? Sounds complicated, but trust me, it's not as scary as it sounds. See, in the world of mechanical engineering, we gotta show our designs in a way that everyone understands. We can't all be staring at the same three-dimensional model, right? That's where orthographic projections come in. Think of it like taking a picture of your awesome Lego creation, but from different angles. You take one picture from the front, one from the side, and one from the top. Put those together, and bam! You've got yourself a set of orthographic projections. These projections are like a flat map of your three-dimensional object. They show every detail, every dimension in a way that's clear, concise, and universal. And trust me, when you're building bridges or designing rockets, clear communication is everything. So, what exactly are we looking at with these orthographic projections? Well, we call each view a projection plane. You've got your front view, which shows the front of your object. Then there's the top view, looking down from above. And of course, the side view showing, you guessed it, the side. Now, here's the cool part. Each view is aligned with the others. That means what you see in the front view lines up perfectly with what you see in the side view, and so on. It's like a puzzle, but instead of getting a pretty picture, you get a super detailed plan for building something incredible. Why is this important? Well, imagine trying to build a car engine with just a picture from one angle. You wouldn't know how deep to make the cylinders, how wide the pistons should be. You get the idea. Chaos. Alright, so how do we actually create these magical drawings? First things first, you'll need the right tools. A pencil, paper, a ruler, and maybe a protractor for those fancy angles. Don't worry, you don't need to be a master artist. Precision is key here, not artistic flair. Next, you'll start with your object. Could be anything from a simple cube to a complex machine part. Now imagine projecting lines from every point on the object onto your projection planes. These lines are always perpendicular to the plane, kind of like shining a flashlight straight on. Where the lines hit the plane, you mark a point. Connect the dots, and you've got yourself a view. Do this for all your planes, and voila! You've created a set of orthographic projections. Of course, there are some rules to follow, things like line types, dimensioning, and symbols, but we'll save that for another day. For now, just remember the basic idea: project, connect, repeat. Let's be real, folks. Learning orthographic projections can feel like trying to speak a new language. But just like any new skill, practice makes perfect. One common challenge is visualizing those projection lines. My advice: grab some Play-Doh or clay and build your own objects. Then grab some toothpicks and practice projecting those lines for real. Another hurdle is understanding how different views relate to each other. Remember that puzzle analogy? Well, start treating your drawings like puzzles. Look for clues in one view that tell you something about another view. The more you practice, the easier it gets to see the connections. And hey, don't be afraid to make mistakes. That's how we learn, right? The important thing is to keep practicing, keep asking questions, and keep that curiosity burning. Because mastering this skill is your ticket to speaking the language of engineering, building amazing things, and maybe even changing the world. Who knows? The next time you see a skyscraper or a spaceship, you might just think, hey, I helped make that happen. And that's a pretty darn good feeling.